Grade 10, we're looking at aqueous solutions, conductivity, and electrolytes from the November 2017 examination, question 7. And there are two important things we need to remember when we are answering a question like this. The first thing is the definition of an electrolyte. An electrolyte is a solution that has free ions that would conduct electricity. This is very important. So only if the solution has free ions will the solution conduct electricity. So something like NaCl, which is ionic, something like potassium nitrate, and all our ionic compounds, they have free ions, so they would be electrolytes. But non-electrolytes would be all our solutions that do not have free ions. Something like distilled water, no free ions, and also a sugar solution, no free ions, because it is a molecular solution. It is covalent and not ionic. So our ionic solutions have free ions to conduct electricity. And the second thing we need to remember is that the greater the concentration of the ions, the more ions per unit volume in solution, the greater the conductivity. It would conduct electricity better, and we would get a greater ammeter reading because we would have more current. So in this question, learners investigate the relationship between concentration of silver nitrate and conductivity at constant temperature. They set up the apparatus as shown and record the current. The initial reading of the ammeter was taken before anhydrous AgNO3 was added to distilled water. The anhydrous AgNO3 was added to 200 cm cubed of distilled water, spoon by spoon, and the ammeter reading was recorded after each spoon was added. The results are shown in the table below. Give a reason why the ammeter reading was initially 0. So initially, if we look at the first reading, we can see the ammeter reading is 0. And that was when there was 0 spoons of AgNO3 in distilled water. So at that point, we just had a beaker, and in that beaker, there was only water present. There were no ions from the AgNO3. So the ammeter reading would be 0 because there are no free ions. Distilled water does not contain free ions. Give one word or term for a solution that conducts electricity. This is an electrolyte. An electrolyte is a solution that conducts electricity through the movement of free ions. Write down a balanced chemical equation to show how silver nitrate dissociates in water. So silver nitrate in water would break up into its respective ions. So it was a solid. It would break up into silver plus ions aqueous plus nitrate minus ions aqueous. And it is very important to include those positive and negative charges. Write down the following for the investigation above: a hypothesis. Now, a hypothesis answers the investigative question. If we go to the top, learners investigate the relationship between concentration of silver nitrate and conductivity. If I've got to ask an investigative question, the investigative question would be, what is the relationship between concentration of a silver nitrate solution and conductivity at constant temperature? The hypothesis is going to answer that question. And right at the beginning, we said that two important things we need to learn and remember is that as the concentration of ions increases, so too does the conductivity. And that would answer the question that as concentration of AgNO3 increases, the conductivity also increases at constant temperature. Make sure we always include our constant variable as well in our investigative question, as well as in our hypothesis and in our conclusion. Dependent variable. To find the dependent variable, we always look at what we measure. So if we go to the top and check what is this learner measuring, they said that the learner recorded the current. Why is he recording current? When we are investigating concentration versus conductivity, because the greater the current or the ammeter reading, the greater the conductivity. So the ammeter reading is helping him to measure conductivity. So dependent is conductivity. But you could have also said the ammeter reading, but it's better to just say conductivity is dependent. And he used the ammeter to help him measure conductivity. The independent variable would be the variable that he changes in each experiment. And we can see that he changes the number of spoons of silver nitrate. He first used no spoons, then he used 1, 2, 3, 4. So he increased the number of spoons of silver nitrate. By doing that, the more silver nitrate he added, the greater the number of ions, or the greater the concentration of AgNO3. So he was increasing the concentration of silver nitrate. The control variable they had given us earlier, they said this was taken at constant temperature. So temperature would be the controlled variable, or we could even call it the fixed variable. Define the term anhydrous. Anhydrous means without water. For example, if I'm looking at copper sulfate dot 5H2O, that's hydrated copper sulfate. Without water, it would just be CuSO4. So CuSO4 dot 5H2O, this would be hydrous or hydrated. And the second one, without that water molecule, would be anhydrous. If the mass of silver nitrate is 5.3 grams per spoon, calculate the concentration after 2 spoons have been added. Okay, so to find concentration, we would need to use an equation, and from the data sheet we know that concentration is mass over molar mass times volume, or you could use concentration equals N over M, but at this point we don't have N. So the mass, they said after 2 spoons have been added, we know that it is 5.3 grams per spoon, so the total mass would be 2 times 5,3 all over the molar mass, and the molar mass of AgNO3, when we calculate silver nitrate, we would get a molar mass of 170. And the volume, we would look at how much water there is in solution. And earlier in the question they mentioned that there were 200 ml in solution. Let's just bring it down. You can see there, just above the table, 200 cm cubed of distilled water. So 200 ml is the same as 200 cm cubed. So that is the first thing. And we know that from cm cubed to dm cubed, we need to do a conversion because dm cubed is our SI unit. We would times by 10 to the negative 3 or divide by 1,000. So that means that the volume is 200 times 10 to the negative 3. And when we put that into our calculator, we would get a concentration of 0.31 mole per dm cubed. Going to the next question, can tap water be used in this experiment? And the reason is no. Distilled water has no free ions, so it does not affect the conductivity of this experiment. But tap water, it has free ions. And this would affect conductivity. From the results, deduce the relationship between ion concentrations and conductivity. And if we go look at the results, we can see the more spoons of silver nitrate that we had, and remember, the greater the number of spoons, the greater the concentration of ions. Because we could see here in 7.3 that when silver nitrate dissolves in water, it forms ions. So the more silver nitrate I have, the more ions I would have, so the greater the conductivity. And from the results we can see that as the concentration is increasing from 1 to 4. Even the ammeter reading is increasing. So just like how we predicted in our hypothesis, we are now going to write our conclusion for this experiment as ion concentration increases, conductivity also increases. A learner accidentally drops hydrochloric acid into the solution. How will this affect the ammeter reading, and explain the answer? So the first thing we need to do, in this solution we have silver nitrate. And the learner has now dropped hydrochloric acid into this solution. And one of the things that we know about silver nitrate, it is used to test for the presence of chloride ions. When this happens, the Ag plus and the Cl minus would react and AgCl would form and nitric acid. And we know that AgCl is actually a white precipitate. So now that a precipitate has formed, we now don't have the silver ions and chloride ions in solution to conduct electricity anymore. But we still have some H plus ions and NO3 minus ions, but the volume has increased. It was originally 200 ml. He dropped some HCl, so let's say maybe till there, maybe the volume of the solution has increased. So the volume of the solution has increased. I still have 2 ions in solution. So although the number of ions in solution are constant, the volume has increased, and we know that concentration is equal to N over V. So the number of ions is constant, concentration is inversely proportional to volume. The greater the volume, the lower the concentration. So the concentration would decrease. And the reason that you would give is, firstly, you would use this reaction that a white precipitate is formed. The volume of the solution increases, but the ions remain constant. And if the volume increases, the concentration decreases. I hope that you have found this video useful. Please like if you did, subscribe so that you don't miss future videos, and share this video with your friends so that more learners can benefit from these lessons.